Today we are going to learn a new concept, piecewise functions. And piecewise functions basically are functions where the domain is, we can say, different for each part. You know, domain are the x values. Those are the values that you actually plug into your functions. And the way that a piecewise function looks, it looks something like this. And they're going to give you at least two. And what happens is they restrict your domain, such as the first function is only for if x is less than 2. Now, it's not going to always be 2, but in this particular case it is. And it's the second function if x is greater than or equal to 2. So if you think about on the number line, here's 2. And for the first function, use blue, this is for all the x values that are greater. So those are the numbers or the x values that we can plug in. And then the second function, I'll use pink, are for all, I'm sorry, I said that backwards. Let's try this again. So for the first function, which is blue, it's for all the x values that are smaller than 2, but not including. So that's all of these values over here. For the second function, these are all the x values that are greater than or equal to 2. So we can only use those values. So for example, they're going to ask you to evaluate f of x at the given values. So they may give you something like f of 4. Well, first you have to figure out, does 4 belong in the domain for the first function or the second function? Well, we know that 4 is larger than 2, so that would be my pink values. So that means that I would use this equation. And then you'll just actually plug in 4 for x. And you would get 8 plus 1, which is 9. So f of 4 would equal 9. Okay, and then what if I gave you f of 0? So then you would have to figure out, does 0 belong in my blue domain or my pink domain? Well, 0 is smaller than 2, so that means that we would use this function. And we would plug in 0 for x. So that means f of 0 would equal 2. So that's just evaluating the function. Now I'm going to give you a function and I want you to try it. Okay, here's your guided problem. I want you to evaluate the functions for the given values of x. So I gave you the two functions, and remember the first one is only for x values that are smaller than or equal to 1, and the second one is for all x values that are greater than 1. So pause the video and try these three, and then we'll check our answers. Okay, so for the first example, my x value is 3, and you know that 3 is greater than 1, so we have to use the second function. Plugged it in, and I got 10. And notice how I'm writing the answers. Make sure I write that right. The second example, x was 1. We know that 1 is less than or equal to 1, so I have to use the first function. And plugging 1 in, I get 1. So f of 1 is 1. In the third example, my x value is negative 4. Well, -4 is smaller than or equal to 1. So I'm using the same function that I used in part B. Plugged in -4 and I got -9. So f of -4 equals -9. Now your function values so far have been labeled as f, but they can be different names. They can use G and H. Those are common names as well. That's just the name of the function, because when it's in the word problem, they usually use letters related to what's going on in the actual situation. So make sure if they give you more than one function, you match the function value, f. Make sure that it's the f function when you're plugging it in. Now, we are going to use what we just learned about evaluating piecewise functions to now graphing them. It's very important that you understand the domain, because that's what's going to help you determine what x values you can use for your piecewise function. So let's try this first example. We'll start off with a basic one. Okay, now what's going on is f of x is the same thing as y, so we're actually graphing two lines, y equals 2 and y equals -1. And when we write it as a function, it's f of x equals 2 and f of x equals -1. Now, for the first one, well, first of all, let's talk about y equals. Remember, that's a horizontal line. So both of these lines we know are going to be horizontal. What is happening is the first line is only restricted for x values that are smaller than or equal to 4. And the first one is only for x values that are greater than 4. I like to graph my piecewise functions using two different colors, because that makes it easier for me to see what's going on. Just put in a couple. Okay, so I'm going to do the first in pink, and the second one I'm going to use blue. Okay, the best thing to do is to actually, now in the first examples, they gave us x values to plug in. Well, now we get to choose. It's a good practice that you always start off with these numbers right here. So for my first one, I'm going to use x as 4. Now, this is saying, if you look back, that all your y values are going to be 2. No matter what x is, your y values are 2. So for my first point that I'm going to actually use, the order pair would be, well, let me use the same color so we won't get confused. 4, 2. So I'm going to go to my graph and plot 4, 2. 4 is included, so I'm going to use a closed circle. Then remember, you need at least 2 points to make a line. I need another x value that falls in this domain. Well, I know it has to be smaller than 4, so I'm just going to pick, you pick anything. I'll pick 2. And what do we say? Our y values are always 2. So 2 is included, so I have to have a closed circle. And if we keep plugging in values smaller than 2, you're going to notice that this number, or this graph, all of these points over here would fall in this domain. So that means that the direction of my line is going to -infinity, and we cannot use anything larger than 4. That's why I went to the left. My second graph, these are all x values greater than 4. I'm going to start with 4 again, but I'm not going to include it. And the reason why I do that, because if you like start at 5, you're going to miss all the numbers on the number line between 4 and 5, that region right there. So I'm going to start at 4, I'm just not going to put a closed circle. In this particular equation, all of my y values are -1. So at 4 and -1, 4 is not included. So I need a number that is larger than 4. So I'll just pick 6. And my y values are -1 again. And if we keep going, we'll notice that this line is going to positive infinity. And there's my piecewise function. Okay? Let's try one where the lines are not horizontal. Okay, here we have another piecewise function, and now we're using 2 as our base number. I'm going to do 2 different colors again. Pink for the first one, blue for the second one. And for the first equation, and if you want, you could take it apart. This is what we're graphing. But we can only use numbers greater than 2. And so since it's a fraction, be careful. You want to use multiples of 2 to make it so it'll cancel out. So remember you always start with 2 though. So I'm going to plug in 2. And I will get half of 2 is 1. 1 plus 1 is 2. 2, 2 would be my first point. And then I'm going to plug in, I'll do 4. Because that's also greater than 2. So half of 4 is 2. 2 plus 1 is 3. So my next point is 4, 3. And then I'll graph. Now, very important, when we plugged in the first one, 2, 2, the 2 is not included. Let me just put my lines. So 2, 2 is not included, so that's an open circle because it doesn't have that equal sign under the inequality. But 4, 3 is part of it is included, so that one's closed. And since it says greater, we know that this is going to positive infinity. Remember, you only need 2 points to make a line. Okay, my other equation, which is f of x equals 2x minus 1, is only for numbers that are less than or equal to 2. So I'm going to use 2 again. And the good thing about this one is now 2 is included. 4 minus 1 is 3, so that point is 2, 3. So I'm going to go to 2, 3. And then I need a number smaller than 2. I'm going to use 0 because that's always easy to plug in. So 2 times 0 minus 1, that equals -1. That point is 0, -1. And since it says less than or equal to, then this line has to be going to negative infinity. So your inequalities tell you which way your line is going to be going. And if you're in doubt, you could just keep plugging in numbers until you see the direction of your line. And then That's that graph. And now let's go even further and try one that has more than two graphs. Okay, here's an example where we have three functions. We're graphing f of x equals 2x, f of x equals 3x, and f of x equals negative x. So my first function, I can only use x values greater than or equal to negative 1. So I'm going to start with negative 1. And I get negative 2. So that point is negative 1, negative 2. Remember, you need 2 points to make a line. So I need something greater than negative 1. I'll use 0. And I get 0. So that point is 0, 0. And so I'll make my graph. So remember, negative 1 was included. So negative 1, negative 2, and 0, 0. And since it's saying greater, we know this line is going to positive infinity. The second graph or function is only for x values between negative 2 and negative 1. So I'm going to plug in negative 2. And if you notice, it's not including. So 3 times negative 2 is negative 6. So that's negative 2, negative 6. I should use a different color. I'm going to use pink. And it's not including, so that's an open circle. And then I'm going to use negative 1. That one's not included. So that's negative 3. So that's negative 1, negative 3. Negative 1, negative 3. And so since it can only be between those two values, then my line will stop right there. And then the last one is for x values smaller than or equal to negative 2. So I'm going to plug in negative 2 because that one's included. So be careful because this is a negative times negative 2, which makes it positive. So that is negative 2, 2. That one's included. And it's best if you use graph paper because you notice my lines, my increments are not spaced out equally. And now I need something smaller. So I'm going to use, I'll use negative 4. And be careful for that negative that's already there. So that'll make it positive. So that order pair is negative 4, 4. That one is also included. And since it says smaller, this one's going to negative infinity. Sorry that it went off the graph. And there are your 3 lines. So basically you have to make sure that whatever x values you are plugging in, they follow your domains. And they fit in those domain values. Make sure you write down any questions you have and we'll answer them tomorrow.